Hi, my name is Talia. I'm a high school senior and I love teaching others about chemistry and math. This YouTube channel is a supplemental resource to anyone who may be having their difficulty in their chemistry classes. This week, I'm going to talk about predicting products and chemical reactions. So I hope that if you need help with that, you will feel free to continue watching. Without further ado, let's get started. So in my last video, I talked about the different kinds of chemical reactions and what each of them look like. So if you need a refresher on that, I recommend checking out my previous video. I'm going to go through each of the chemical reactions and explain what the product will look like now so that we can learn predicting products. So first we have a synthesis. And as I mentioned in my previous video, synthesis reactions will start with two elements or an element in a polyatomic ion, and they will have one product, which is a compound. So to predict the products for a synthesis reaction, you just combine the elements and balance their charges to have the formula of the product. So next we have a decomposition reaction, which is kind of the flipped version of a synthesis reaction. We start with a compound that is a reactant, and it is broken up into two elements or an element in a polyatomic ion. So with these, you are just going to do the opposite of a synthesis reaction. You are just going to write the elements or element in polyatomic ion separately as products. And also you want to remember Hoff-Brinkel or Brinkel-Hoff when applicable, because diatomic elements need to be written as like Br2 or Cl2 when they are by themselves. So for instance, if you want to decompose NaCl, that is going to decompose into Na and Cl2 because chlorine is diatomic. You cannot write Na and Cl. And that then changes your balancing because you now have to add 2 in front of the NaCl and multiply and add a coefficient of 2 in front of the sodium. So just remember to write diatomic elements with a subscript of 2. Next, we have a single replacement. And in a single replacement, the reactants are a compound and an element, and the products are also a compound and an element. So you want to classify the reactants and determine which will switch. And as I said, metals switch with nonmetals, nonmetals switch with nonmetals. So you balance the charges of the elements in the compound in your product in order to determine the formula of the product. Continuing on, we have a double replacement. So that has two reactants and two products. Both of the reactants are compounds and both of the products are compounds. So just like a single replacement, metals only switch with metals and nonmetals only switch with nonmetals. And to remember how to do the switches in a double replacement, I like to remember outsides together, insides together. So if you have, let's say NaCl plus KBr, your outsides are going to go together to get NaBr, and your insides are going to go together to get KCl. And then your metals and nonmetals have switched. And for multivalent metals, the charge will be determined from the reactant side. Next, we have neutralization reactions. So the reactants will be an acid and a base. Acids start with an H and bases end with OH. So one of the products will be water, which can be written as HOH for balancing purposes, and the other is a salt. So a salt is any ionic compound, and the formula for a salt will be the beginning of the base and the ending of the acid with the charges balanced. So the beginning of your acid will be H, the end of your base will be OH, those two will come together to make H2O, and then the end of your acid and your beginning of your base will come together to make the salt. Obviously, you're going to have to balance the charges and the coefficients, but that is the basis of it. And finally, we have a combustion reaction. The reactants are hydrocarbon and oxygen, and the products are CO2 and H2O. The products will never change. Just make sure that you balance oxygens last. Because oxygen is in 2 of the products, it's going to be really difficult if you try to balance oxygen first. I recommend first balancing carbon, then hydrogen, then oxygen. And just a final note, if you have more than one product in your reaction, doesn't matter which order the products are written in, just as long as you make sure you first write metals and then nonmetals. Okay, so now we're going to practice predicting some products. First, we have Ta and Cl2, and we know that those are two elements as reactants. So this is a synthesis reaction, and our product is going to be a compound. So I'm going to write out the compound by using the charges for tantalum and chlorine. So tantalum has a +5 charge, and chlorine has a -1 charge. So our product is going to be TaCl5. Now I need to balance. So I'm going to draw my chart and write how many tantalums and chlorines I have on each side. I have 1 tantalum and 2 chlorines on the reactant side, and 1 tantalum and 5 chlorines on the product side. I cannot multiply chlorine by any whole number coefficient in order to go from an even number to an odd number. So I'm going to find the greatest common multiple between 2 and 5, which is 10. And I'm going to use my coefficients to make sure there are 10 chlorines on both sides, because that is the least number of chlorines I can get by using whole coefficients. So I'm going to put a 5 in front of the Cl2. That will make 10 chlorines on the reactant side, and a 2 in front of the TaCl5, which will give me 10 chlorines and 2 tantalums, which will mean that I have to put a 2 as a coefficient in front of the tantalum on the reactant side. So now I have 2 Ta plus 5 Cl2 yields 2 TaCl5. And I'm just going to write that this is a synthesis reaction. Next, we have ZnCl2 and Na. So we have a compound and an element, which means we have a single replacement. We've checked off that first step. Now we need to classify which element is a metal and which is a nonmetal. So zinc is a metal, chlorine is a nonmetal, and sodium is a metal, which means that the zinc and the sodium are going to be switching places. So that means that my compound on the product side is going to have sodium and chlorine. So I'm going to balance the charges to write my compound as NaCl, because sodium is +1 and chlorine is -1. And now since the sodium switched with the zinc is now going to be on its own. Okay, step 1 done. We have predicted the products. Now we need to balance. So I'm going to write out my chart. On the reactant side, I have 1 zinc, 2 chlorines, and 1 sodium. On the product side, I have 1 zinc, 1 chlorine, and 1 sodium. So all I need to do is get the chlorines to 2. So I'm going to put a 2 in front of the NaCl on the products, which will give me 2 chlorines, but which will also give me 2 sodiums. And now I have to fix that on the reactant side. So I'm going to put a 2 in front of the Na. And now we have our reaction. And this is a single replacement because we had 1 metal that switched places with the other metal. Okay, so I'm going to do the final example on a separate page because I ran out of room. This reaction is Ali3 plus HgCl2, and we want to know what it yields. We are starting with 2 compounds, which means this is a double replacement, and we are going to end with 2 compounds. And we know that it is not a neutralization because there's no compound that starts with H and there's no compound that ends with OH, so there are no acids and bases. And we know it is not a combustion because there are no hydrocarbons and there's no oxygen by itself. Okay, so I'm going to classify each of the elements in the reactants as a metal or nonmetal. Aluminum is a metal, iodine is a nonmetal, mercury is a metal, and chlorine is a nonmetal. So if we have outside switch and inside switch, we are going to now write the formula for our products. So we have Al and Cl. Aluminum is a +3 charge, chlorine is a -1 charge, so that is going to be AlCl3. Then we have mercury and iodine. Mercury can have a +1 or a +2 charge, and iodine has a -1 charge. So now we need to figure out which version of mercury is being used in the reactants so we can keep it consistent with the products. So I'm going to move this up a little bit. So if we have two chlorines and chlorine has a -1 charge, we know we have a -2 charge on the nonmetal, and we need something to balance that out and get a total of 0, so that we can have a neutral charge on the whole compound. So that means we are going to be using mercury 2. So in our second compound for the product, we have mercury and iodine. If I have mercury 2 plus and iodine has a -1 charge, our compound is going to be written as HgI2. Okay, now we need to balance. So let me draw my chart. And I have aluminum, iodine, mercury, chlorine. On the reactant side, I have 1 aluminum, 3 iodines, 1 mercury, and 2 chlorines. Now on the product side, I have 1 aluminum, 2 iodines, 1 mercury, and 3 chlorines. So I'm going to choose to start by changing the iodine. So I cannot multiply Ali3 by anything to get 2 atoms of iodine. So I'm going to use the common multiple between 3 and 2 and make sure that I have 6 iodines on both sides of the reaction. So I'm going to put a 2 in front of Ali3, which will give me 2 aluminums and 6 iodines. And then I'm going to put a 3 in front of HgI2, because that will give me 6 iodines on the products, but it would also give me 3 mercuries. Now I'm going to fix the aluminum on the product side by adding a 2 to AlCl3, which will give me 2 aluminum there and 6 chlorines. Now I'm scanning to see what else will need to be fixed, and I see that my next element I need to fix is mercury. So I'm going to put a 3 in front of HgCl2 to get 3 mercuries and 6 chlorines. So now I have balanced all of the elements. I'm going to rewrite my reaction. It's 2 Ali3 plus 3 HgCl2 yields 2 AlCl3 plus 3 HgI2. And this is a double replacement. I'm just going to abbreviate it as DR. That was the end of this week's video. I hope you were able to solidify your understanding of predicting products. Next week, I'm going to talk about balancing reactions algebraically, which should be a fun, little bit more of an advanced method for balancing when the reactions are a little bit more complicated. So feel free to join me back next week if you need help with balancing reactions algebraically. If you have any questions, feel free to leave them in the comments and I will do my best to answer them. I will also put a link in the description box to my website if you would like to schedule tutoring. Again, I hope you enjoyed this week's video and good luck with learning the rest of your chemistry.